I have 21. Now, which of the following statements regarding the application of electrical conduction via gases is or are correct? Now, the electrical conduction in the gas is applied in identification of gases, that's correct. Lighting of fluorescent tube, that's correct. Photocells, no. Photocells is only applied to light energy from the sun, or just light energy. And cathode rays. So the answer is going to be 1, 2, and 4. 1, 2, and 4. Where is 1, 2, and 4? 1, 2, and 4 on the C. Number 2, okay. A missile is launched with a speed of 75 meters per second at an angle of 22 degrees above the surface of the warship. Find the horizontal range achieved by the missile, ignoring the effect of air resistance. So, we are going into projectile. So this is a question on that projectile, and according to the range of a projectile is u squared sine 2 theta all over g, and r is equal to, they gave me u is what? 75 squared sine 2 times, what is the theta there? Theta is 22, another issue, all over 10. This is not a special angle. Why JAMB is bringing this? Okay, fine. This is 2 times 2, 2 times 2, which is 44. So I will say 75 squared, 5625 sine 44 degrees all over 10. This is going to be 562.5 sine 44 degrees is equal to R range. So divide by 10. Okay, so this is 562.5 sine 44. 390. I have 390.7, which is 390.7 meters, which is approximately 391, and that is option A. Going to the next one. Okay, thank God we have. Name the type of equilibrium for each of the position A, B, C. A is going to be unstable, B is going to be stable, C is going to be neutral. Unstable, unstable, stable, neutral, B. The next one is the property of a wave shown in the diagram below is going to be this, the fraction, by fraction. Sure. Calculate the absolute pressure at the bottom of a leg at a depth 32.8 meters, assuming the density of the water is 10 raised to power minus 3. Density of water cannot be minus 3. That cannot be minus, that should be 1000 kilogram per meter cube. So that should be changed. Sorry about that. So we have now, if this is the leg, this is the depth of the leg, from the beginning to this is 32.8 meters. So there is atmospheric pressure acting on it. There's atmospheric pressure acting on it, and there is the pressure at the bottom, PB. So I'm going to say that pressure at the bottom is equal to atmospheric pressure, P atmospheric pressure, plus pressure due to this height, sometimes H. But this, in this case, this height is due to the water column. So I'm going to find the density, multiply everything here as the pressure due to this height. Because the atmospheric pressure was given in Pascal. Yes, I have to solve this one to be in Pascal as well. If not, I would have just added this plus 38. But I have to convert this to make it to be in Pascal. Alright, so what I'm going to do now is to say that pressure due to 32.8 is equal to height is 32.8 times. Density is 1000 times 10. This is going to be 328,123. This is in Newton per meter squared. But we are not dealing with Newton per meter square, we are dealing in Pascal. 1 Newton per meter square is something as 1 Pascal. Therefore, P is equal to 328,000 Pascal. But when I divide it by 1,000, it's cancelled. I have that this is going to be 328 kPa. Because I have to put it in Pascal. Now, when I have gotten this 328, then I have to add it to the atmospheric pressure. So that is going to be that P at the bottom is going to be atmospheric pressure is 101.3 kPa plus, which is 328 kPa. PB is equal to, this is 9.3 kPa. Is that correct? Oh my God. The issue there is that I am using G as 10. Yeah. But G was used as 9.8. So I need to correct. This is 9.8. So I have to go back in order to have a sure value for this. So this is going to be 32.8 times 9.8. Then times 1, no, just that will give me the answer. Times 1, yes. So 321.44. So 321.44. Everything has going to be 321.44 kPa. So I'm also going to add this 321.44. So in that case, this is going to be 422. That is 7 kPa. It's going to be the pressure at the bottom, and I have that in option B. Now we have a question on AC circuit, simple AC circuit. We have that a 120 volt AC voltage source is connected across a pure 25 millihenry inductor. Find the current through the inductor if the frequency of the source is 120 Hz. Okay, so V through the inductor is going to be the current of the inductor multiplied by the inductive reactance. So from this question, I have that inductor is 25 times 10 raised to the minus 3 Henry. So, but this particular value, which is inductive reactance, is given as 2 pi FL. So this is going to be, okay, I'm looking for current, fine. So this is 2 pi times frequency is 120 all over pi. Sure. 120 over pi multiplied by 25 times 10 raised to the minus 3. Alright. This pi cancels this pi. So XL is equal to, okay, we have, this is 240 times 25. 240 times 25. 600. 600 times 10 raised to the minus 6. Milli, of course, it's milli. So this is ohm. But this V is 120, so I'm going to have 120 is equal to current, I don't know, all over this, which is, okay, let me break this down. This is going to be 6 times 10 raised to the 3 times 10 raised to the minus 3. Everything here is 1, so everything here ends at 6. So I is going to be 120 divided by 6, which is 20 ampere. So the current is 20 ampere. We have that there. Okay, option B. Now, the light of wavelength 589 nanometer in vacuum. So the wavelength in vacuum, okay, let's say in V is equal to 589 times 10 raised to the minus 9 meters. Okay, in vacuum passes through a piece of fused quartz of index of refractive index 1.45. So refractive index is 1.458. No unit, it doesn't have unit. What is the frequency of the light in the fused quartz? Frequency of the light in the quartz, alright? Okay, so what I'm going to do is refractive index is equal to the velocity in the vacuum, let me call it C, velocity in the vacuum, CV, all over velocity in the quartz. That is the speed in vacuum and the speed in the other medium. So refractive index is given as 1.458. This is equal to this speed in vacuum is given as, it's given as 3 times 10 raised to power 8 all over V to this one. So we say V through this quartz is given as, if I have 3 times 10 raised to power 8 divided by 1.458 is giving me 2.06 times 10 raised to power 8. Yeah, because 3 divided by 1.458 is 2.06. Alright, in meters per second. So I've gotten the velocity through this medium. Alright, the next thing is I'll also find the wavelength, because I cannot find this one, I cannot find frequency without the wavelength. So the speed through this first medium is going to be what? The frequency of that medium times wavelength of that medium. Now, I don't have the wavelength of this particular medium quartz. So what I'm going to do is to find it. How do I find this one? I've also said the refractive index is going to be the light is passing through the vacuum to that same place called quartz. So do I have this? Yes, I still have it. But I don't have this. I will find it. Once I find this, I have gotten my answer. So this is going to be equal to 589 times 10 raised to power minus 9 all over this. But remember, this particular value is 1.458. So this is going to be 589 times 10 raised to power minus 9 all over 1.458, which is going to be equal to. So we just have 589 divided by 1.458, which is 404 times 10 raised to power minus 9 meters. Alright, like I told you, this is what I'm looking for. Now I've gotten this, I can now find this. Okay, so I'm going to have this. I would say frequency of that medium is equal to velocity V of that one is given as VQ. Okay, look at this. So which is 2.06 times 10 raised to power 8 all over this one, velocity all over what? Because see, V over this, okay, right? This is 404. 404 times 10 raised to power minus 9. So it's going to be 2.06 divided by 404. 2.06 divided by 404. So this is 5.1 times 10 raised to power minus 3 times 10 raised to power. This goes up is plus, so this is 8 plus 9. So this is the frequency is going to be 5.1 times 10 raised to power. This plus this is 17. 17 minus 3 is 14. 14 yes, that's correct. Okay, we're going to the next question. 27. Not okay. Alright, in this question, the voltage V across the capacitor, is the capacitor inductor, is 120 volts. Then the inductor itself is 25 times 10 raised to the power minus 3 Henry, because that M at that H is the milliliter, which is 10 raised to the power minus 3. Then I was given a frequency which is 120 all over pi hertz. Okay, so for me to find this, V across the inductor is current across the inductor and capacitive and inductive reactance. So I am looking for the current, but before that, let me deal with this one. Inductive reactance is given as 2 pi FL. So inductive reactance is 2 times pi times frequency of the pi is 120 all over pi times inductor, which is 25 times 10 raised to the power minus 3. This cancels this. XL is equal to 2 into this is going to be 240 times 25 times 10 raised to the power minus 3. I think XL is given as this. What is 240 times 25? 240 times 25, 600. 6,000 times 10 raised to the power minus 3. XL is going to be 6 times 10 raised to the power 3 times 10 raised to the power minus 3, which is 6 ohm. Yeah, 6 ohms. Alright, inside this formula, I will slot in this and slot V into this. So this implies that 120 is equal to current times 6. So current is 120 divided by 6, which is 20 ampere. So that is the current which is in option D. In number 28, it said an air bubble of radius 4.5 cm cube of cm, radius is cm, initially at a depth of 12 below the water surface, rises to the surface if the atmospheric pressure is equal to 10.34 meter of water, the radius of the bubble just before it reaches the water surface is. So in this kind of question, you need to understand that when we are talking about atmospheric pressure through a depth, so this value is 12 meters. So the atmospheric pressure is pushing on this surface because they say that air abhors a vacuum. So anywhere there is an open space, atmospheric pressure must act in any direction. So, but there is the pressure at this bottom, at this level, due to this column. So we're going to say the pressure at this bottom is 12 plus atmospheric pressure. Right? So that is the pressure at this level. Now, but then the question is talking about a bubble. The bubble here, this is how the bubble behaves. You know, the bubble will start from small and increase in height as it's going up. Why? The reason is that pressure at this place is less. Pressure here is too much, so the pressure is squeezing them when they are there. So as the pressure is, as they are going down, they are becoming small because pressure is increasing as they are going down. But as they are coming up, the pressure is leaving them and they are becoming bigger. So because of that, the radius here must be bigger than the radius here. That is the idea. So in this case right now, what I'm going to do is to say that P1 V1 is equal to P2 V2. Why am I saying that? Because pressure here is different from pressure here. Volume here is different from volume here. Now, what is V1? V1 is going to be 4 over 3 pi r cubed. Why? Because it's a sphere, it's a spherical shape. That is bubble is a spherical shape. So that is going to be 4 over 3 times 22 over 7 times 4.5 all raised to the power 3. So V1 is given as, so 4 divided by 3 is 0. Is the same thing as 1.3, okay? 4, I'm going to have 4 times 3 times 4.5 times 4.5 times 4.5. And that is going to be 10 93.5 and divide by 21. Times 22 Okay, the volume at that level is 381.86 cm cube. So the volume at that depth is that one. So the pressure at that depth too, if the pressure is equal to this, the radius of water just before the surface, okay, fine. So the pressure P1 at that depth is going to be 12 plus atmospheric pressure is 10.34, which is this is going to be 22.34 meter of water. That is the pressure P1, V1 or P1. Now, P2 is going to be pressure at the surface, which is given as 10.34 meter of water. So the pressure at the volume at this point, I don't know. So I'm going to put this value. I have 381.86 times the V1, that is V1, P1 is going to be 22.34 is going to be equal to P1 is 10.34, that is P2 times V2, I don't know. So this times this divided by this is what I'm going to punch in my calculator. This is times 22.34 divided by 10.34, and that is V2 is given as 825.02 meter cube, not meter is cm cube. So at this point, I have not found the radius of this volume. I found the volume of the sphere at this point, so I need to find what it is. So V2 is equal to pi r cube. So this is 825.02 is equal to 4 over 3 times 22 over 7 times r cube. So what I will do is this. I will have that 22 over 7, 22 times, this times this is 88, this times this is 21. 88 divided 21. And that is 4.19. So this is going to be 825.02 divided by 4.19. Okay, so I have that R cube is equal to, so please, I have that R cube equals 196.90. So R is equal to cube root of 196.90. R is equal to cube root 196.9. 5.82 cm. That is the radius at that length. So 5.82, correct? So we go to 29. In this question, a car lifts compressed air exerts a force on a small person of circular cross-sectional area having a radius of 10 cm. So I'm going to have F1 over F2 is equal to A1 over A2. So the A, because it's a circular face, is going to have A1 is going to be pi r squared by r1 squared, and then A2 is going to be pi r squared 2. So force, so what are we looking for? This pressure is transmitted by an incompressible liquid to a second person of radius 20. What force must be compressed, must the compressed air exert on the small person in order to lift a car weighing this? Okay, so we have the first one, which I'm going to say F1 is going to be, let me call this one, which is 15,500. I don't know F2, which is F1, which is going to be pi. R is 10 cm squared all over pi. R2, which is 20 cm squared. So pi cancels pi. So in this case, I'm having that. So if I simplify this further, if you have this fraction, this divided by this multiplied by this, F2 is going to be option C is going to be Alright, so going to the next one, number 30. A half-life of a radioactive material is 12 days. What is the decay constant? Half-life is equal to 0.693 all over decay constant. The half-life is given as 12 days, 0.693 all over. So this is going to be 0.693 all over 12. So 0.693 divided by 12, which is 0.05775. Okay, so the next one. Alright, so I have this question. I'm going to use triangle of forces. Find the tension in the cord shown in the diagram below, neglect the mass of the cord and assume that the angle is at 8 degrees. Another issue, that 8 degrees is not a special angle, so a scientific calculator for this problem should be advised to be used. And in this case, I'm going to have this. There is a force in this particular one which is called T1. And then one goes this way. The one that goes this way is T2. Then there is one that goes this way. That one which is W. So the angle here was theta, and this same theta is here. So this is my T1, this is 38 degrees because this is 38 degrees. They are parallel. Parallel lines gives birth to this alternate angle. So the mass is 220 times 9.8. 220 times 9.8. So we have 2156. 2156. Alright, so I'm looking for find the tension in the two cords. The tension, so I'm going to have T1, this one is going to be this, okay, opposite over hypotenuse sine 38 is equal to 2156 over T1. So T1 is equal to 2156 over sine 38. So 2156 sine 38 sine 38 is 0.61. So this is going to be 2156 all over 0.61616, and this is going to be 2156 divided by 0.61635. That's 3500. Okay. So my T1 is 3500 Newton. So let me find T2. I can use Pythagoras theorem to find that out. Let me use 7, one I'm using here. So what I'm going to have is that this over this, so cos 38 degrees is going to be T2 over 3500. So T2 is what? 3500 cos 38. 2758. So this is 2758.0 Newton. So which one has 35 and 27? No. T1, I found my T1, 35. T1 is 35. Yes, T2 is this. So that's correct. Oh no. Sorry, I have this one. Okay, B is correct. Going with that one. Okay, 32. Alright, coming to this one. Alright, so at 45, you need to be careful. Look at this. So this is 45, 46, 47. So it's going to be 47 over 100 plus. The next one is, this is 6, this is 3.5, 4, 4.55, 5.56, 6.5 plus 6.5. So this is 0.47 plus 6.5, which is going to be 6.97. 6.97 is there, option C. The next one, right? He said an object weighing 420 in air is immersed in water after being tied to a string connected to a balance. The scale now weighs 380 Newton. Find the density of the object. Density of water is 1000 and use 9.8. Alright, this is a question on Upthrust, and Upthrust says weight in air minus weight in water. So weight in air is 420 minus weight in water is 380. So Upthrust is 40 Newton. But Upthrust is the same thing as, according to Archimedes' principle, Upthrust is the same thing as the weight of water displaced or weight of liquid displaced is equal to Upthrust. So this is the Upthrust, and it must be equal to the weight of the liquid displaced when the body was immersed in liquid. So we're going to say that 40 is equal to mass of the liquid times acceleration due to gravity. But then density of the liquid was equal to mass of the liquid all over volume of the liquid. Therefore, mass of the liquid is going to be density of the liquid times volume of the liquid times acceleration due to gravity. Now 40 is equal to, the density of the liquid is 1000. Volume of the liquid is unknown times 9.8. This cancels this. This is 2 and this is 50. Right. So say VL is equal to 50 times 9.8. 50 times 9.8. 490. So this is going to be 2 divided by 490, which is going to be equal to 2 divided by 490. 1 all over 245 meter cube. I'm sure it's meter, not cm. Okay, meter cube. This is the volume of the liquid. Now remember, according to Eureka can or Archimedes displacement can, he says that the volume of the liquid is still equal to the volume of the object when fully immersed or partially immersed in a liquid. Therefore, the density of the object is equal to mass of the object all over volume of the object. But I don't know the volume of the object. That is what the question is looking for. I mean, density of the object is what the question is looking for. But the mass is going to be 420. 420 divided by 420 divided 9.8. Okay, so this is going to be 42.886 divided by, this is the mass because the weight in air divided by G, and my G is 9.8, is giving me this value, all over the volume. Now, volume of liquid displaced must be equal to volume of the object. I stated that. And this is going to be 1 over 245. 1 divided by 245 is going to be 0.0040. I mean 1. Okay? So that is going to be 42.86 divided by 0.0041. Now I have 10,453. 10,4, I mean 1.04 times 10 raised to power 4. Yes, this is the option. I mean 0.4, okay, yes, it's still the same thing. 0.5, so this option is correct. Going to the next one. Which of the following thermometers measure the temperature of the thermal radiation emitted by object? Thermal radiation emitted by object, we have thermocouple. It can never be thermocouple. Thermocouple is a heat, is a kind of, measurement of temperature by the principle of heat energy. Why this one is barometer? Pyrometer must be the absent because platinum resistant, this is a resistant thermometer, and constant gas thermometer, it cannot be. Constant pressure, no. The option is B. Alright, so we are going to solve this question. The number of holes in an intrinsic semiconductor. Intrinsic is a pure semiconductor that has not been doped. So its level of conductivity is still the way it is untampered. So option A is saying is greater than the number of free electrons. No, it cannot be greater. B is less than the number of free electrons. No, it cannot be less. Is not equal. No. D is the right option. Is equal to the number of free electrons. So the number of holes must be equal to the number of electrons in a semiconductor. Intrinsic semiconductor. Now, in this option, it's like you answered before, but torque is the right thing. Momentum is not correct. No, momentum is kilogram per meter, kilogram meter per second, not this one. Power must be only watt, not watt per second. Pressure, this is correct, and torque. Pressure and torque is the right thing. So the next one is which process is responsible for production of energy in the stars? When we talk about the stars, we talk about the sun. But then the kind of nuclear energy in the sun is fusion, not fission. It's fusion. This is the kind of nuclear energy that even mankind has not been able to, to produce. So the option there must not be fission. Is nuclear? No, it's fusion. Fusion is correct. Fusion. Number 38. All right. Let's go to this one. We have the velocity v of the wave set up by plugging a stretched string is found to depend on the tension T in the string. Its length L and mass M is given by V. Okay. The formula is given by V is equal to K T raised to power X L raised to power Y and M raised to power Z. So what is V? Let's go back. We said the velocity. Okay, V is velocity. Therefore, velocity is going to be LT minus 1 according to dimension. I do not know K. T, what is T there? T is the tension. Tension means force. Force is mass times acceleration. Mass is kilogram, which is capital L. Acceleration is LT minus 2. So this is going to be M LT raised to power minus 2 all raised to power X. L is just the length. L, what is L according to the question? L is length, so L is just there. M, what is M? Mass, okay. Mass is also going to be M raised to power Z. M raised to power Z. Okay. So I am going to now, since I have M here, but I do not have M here, I must include M here by just 1. M raised to power 0 is still the same thing as 1. So L raised to power 1, T raised to power minus 1 is equal to K. M, so this X will be affecting here, which is X. It will affect this one, becomes L raised to power X. It also affects that, which is minus 2X. This is according to the distribution law of indices. And this is L raised to power Y, M raised to power Z. Alright, so I am going to, should I say collect like terms? No, apply law of indices. Because all M must, M raised to power 0, L raised to power 1, T raised to power minus 1 is equal to K is a constant. It does not have a dimension. So M is going to be X plus Z. Because base M and base M, their power should be added according to the law of indices. they also add X plus Y, and T minus 2X. Alright, I'm going to be equating them. According to exponential equation, when you have the same based on the two sides of the equation, the powers will be equated. So that means m raised to power 0 is equal to m raised to power x plus z. This means that 0 is equal to x plus z. Does that mean that x is equal to minus z? Correct? So the next one we have L. So this is going to be x plus y is equal to 1. That means L. Okay, so this plus this, so this is going to be x plus, never continue this. Okay, fine. Let me wait first and see what happens. So t is going to be minus 2x is equal to minus 1. So x is equal to 1 over 2. So I've gotten x is y that I'm yet to get. Okay, so my y, x is equal to 1. Okay, so if x is 1 over 2 plus, I don't know y is equal to 1. So y is equal to minus 1 over 2, because 1 minus 1 over 2 is minus 1 over 2, and that means x, no, z. Z is going to be minus 1 over 2, because if I take this minus to this place, z is going to be minus x. And if x is 1 over 2, z is going to be minus. So I have this, and I have this. Do we have any of that here? So x is 1 over 2, correct? Y is minus. X is 1 over 2, correct? Y is no. X is 1 over 2, y is 8. Option C is the correct option. Because x is 1 over 2, y is minus 1 over 2, and z is minus 1 over 2. Alright. Now, on a particular hot day, the temperature is 40 degrees Celsius and the partial pressure of water vapor in the air is 38.8 millimeter mercury. What is relative humidity? Relative humidity has to do with temperature at dew point. No, the pressure at dew point all over the pressure at SVP. But in this question, we are using partial pressure. Okay. It must be partial pressure and the SVP. The SVP table is there given to me. And that partial pressure is 40. That 40, no. We have this value here. I'm using this value, 38.8 is going to be my numerator. So relative humidity is going to be that value there, which is 38.8 all over. The one at SVP is going to be 55.3. Yes, because 38.8 divided by 55.3, which is times 100 over 1, which is 70.1. Okay, correct. 70 is there. Option C. Alright, the last but not the least, how much network is required to accelerate a body? How much network? How much network? How much network? Network, that is, net means change, minus, is required to accelerate a 1,200 kilogram car from 10 to 15. Network means change. Okay. Work, change in kinetic energy is equal to the work done. And that is the network. What is the mass is given there? So half mv squared minus half mu squared is equal to the work done. 1 over 2 m bracket v squared minus u squared is equal to work. 1 over 2 times mass is 1200, right? 1200, okay. Bracket v is final velocity, which is 15 squared minus 10 squared, which is equal to the work done. 15 plus 10 bracket 15 minus 10. This is 25 bracket This is 5. 5 times 25, 5, 10, 2, 125. So work is equal to 1 over 2 times 1200 times 125. This is 600. 6 times 125. 600 times 125. 75,000, which is 75k, which is 75 times 10 is 1. 1,000 is 4 joules. Option D. Thank you for being part of this class, and God bless you.